This question is also the same concept logic, guys. Only thing is here you have to understand what is the actual delay it is happening in the question. Here two parts are there in the question. One day Isha started 20 minutes late from her home and reached her office 40 minutes late while driving 75% of her usual speed. How much time in minutes does Isha usually take to reach her office from home? No rush, please. If you give answer so fast, you will not get marks. You have to give correct answer within the limited time. Okay. Please listen to the instructions, guys. You can break the question into two parts. Okay. One day, Isha started 20 minutes late from home to office and reached her office 40 minutes late. Okay. That is the first part. Students, please hold on for a moment and listen to the instructions. Please hold on for a moment, because if you get wrong answer, you will be disappointed. That's my worry. Okay. Just hold on for a moment and check whether you are thinking about the question in the same manner or not. If there are any changes, then why it is the same, I'll help you to sort it out. Okay. So one day Isha started 20 minutes late from her home and reached her office 40 minutes late. So this is first part of the question. Done. While driving 75% of her usual speed, how much time in minutes does Isha usually take to reach her office from home? If this is the question, we know 75% of his usual speed means we know this part. We know the other part, right? The new speed is equal to 75% of usual speed. So 25 threes, 25 fourths, I can write the new speed divided by the usual speed is equal to 3 by 4. So new speed equal to 3 parts, usual speed equal to 4 parts. From this, as we already know, speed is inversely proportional to time. We can directly write new time divided by usual time. New time divided by usual time is equal to 4 by 3. So new time is 4 parts and usual time is 3 parts. Done. And what is the question here? How much time in minutes does Isha usually take to reach her office from home? So how much time in minutes does Isha usually take to reach her office from home means we have to find out this T usual, which is nothing but 3 parts. Okay. So how can I find that? If I have to find out that, I have to understand what is the difference between new time and usual time. What is the difference between new time and usual time means how many minutes of late is happened in the story of the question. Okay. How many minutes of late is happened? Now, please tell me, one day Isha started 20 minutes late from her home and reached her office 40 minutes late means total delay is 20 minutes, 60 minutes, 40 minutes, 80 minutes. This is the confusing part, guys. If you are able to understand what is the total delay, then you can answer the question very easily. So there are 4 choices where we can think that the total delay can be 20, can be 60, can be 40, can be 80. Okay. Thank you all so much for the response. Let me explain by eliminating each of the values of wrong answers, guys. So here in the question, I can eliminate 80, I can eliminate 40, I can eliminate 60, 20 is the correct answer. Only 20 minutes of delay happened in the question. So if that is how means, please listen to the explanation. One day Isha started 20 minutes late means, okay, she started 20 minutes late. Actually, let's say that she need to start by 9 o'clock. She started around 9:20. Done. If she is maintaining the same speed, let's say that if she need to reach the office by 10 o'clock, she will reach by 10:20. Okay. So with the speed, it is not having any effect. She started late, that is the reason she reached late. But there is no effect of time change because of the speed that she has maintained. Okay. Try to understand. I'm not reading the question like a condition of the question. I'm giving you some other example. Okay. Let's say that Isha should start at 9 o'clock and she started 20 minutes late and she maintained the same speed. Actually, here she maintained 75% of her usual speed, means her speed got decreased by 25%, right? Her speed got lowered by 25%, right? But if she would have maintained the usual speed, her 100% potential or her 100% speed, then she might have reached the office by 10:20. Just the starting delay will be implying at the destination. That's it. But what happened here? She traveled with only 75% of her speed, not with 100% of her speed. Okay. Because of that, so she reached her office 40 minutes later. She reached her office 40 minutes late means actually she need to reach by 10 o'clock. She is reaching by 10:40. Okay. She is reaching by 10:40. Okay. That means with the base time 10 o'clock, it is 40 minutes late actually. Okay. But out of the 40 minutes, you have to subtract 20 minutes because that 20 minutes is not because of the speed. Okay, whatever the delay that has happened in the starting, while starting at the home itself, the 20 minutes is not because of speed. Because of speed, how many minutes of time got affected? As she got lowered her speed by 25% and she did not travel with her 100% speed, she traveled with her 75% of her speed. Because of that, extra 20 more minutes of delay has happened. Otherwise, if she would have maintained the same speed, then she might have reached by 10:20. Okay. Try to understand why am I subtracting this 20. This 20 minutes of start time is not having any effect on speed or time or journey value. Why? Because at starting only it was a delay. It was not affected by speed, time or distance. Okay. That's the reason out of total delay, I can write here like this. Total delay is nothing but 40 minutes. This is a start delay, right? So this start delay will not be having effect on the journey. So this 20 minutes of late has happened because she decreased her speed. That's the reason I can say that the difference between new time to usual time is nothing but 20 minutes only. Only 20 minutes of delay has happened. So one part, 4 minus 3, 4 and 3 here, right? One part equal to 30 minutes. Sorry, one part equal to 20 minutes. And they're asking me to calculate the usual time taken by Isha to reach the office. That is nothing but 3 parts. 3 parts equal to how much? That is 3 into 20, which is equal to 60 minutes. That is 1 hour. So my point is, you might have answered this question, but next time whenever they mention like this, you should be not having any trouble to answer it, guys. Okay. I'm reiterating the explanation once again. 75% of usual speed means there you can easily write new speed by usual speed is 3 by 4. Then as speed and time are inversely proportional, new time to usual time is 4 by 3. I can understand that one part of difference is there for time. And if the same you can apply for the how many minutes of late has happened in the journey, then you can answer for the question of usual time taken by Isha to reach the office. So starting only it was 20 minutes delay. If it was 20 minutes delay in the starting, then that will not be having effect in the journey of time, speed, distance, because she has lowered the speed by 75%, like a 25%, you will be having certain delay for sure. So if you want to find out what is the delay that which was affected by time, speed and distance, then you have to eliminate the starting delay out of the total delay, which is 20 minutes. That's how I got total delay equal to 20 minutes. So is it clear now, guys? Is it understandable why I have eliminated 60, 40 and 80? Next time when they change the names and times of minutes, can you be answering the question? Will you be answering the question? Is it clear now? Shall we go for the next one? Yes? Okay. Let's go for the next. If you have any queries or if you think that any other method can be possible here or any shortcut, you can post the same in Q&A or chat box. So if we can understand that 20 minutes is delay, this much of time will not be consuming, guys. From next time onwards, whenever you see the storyline, you can directly answer for the question. Okay. Let's go for the next. A man goes from his house to office at a speed of 20 km per hour and reaches 15 minutes later. If he increases his speed by 5 km and reaches his office on time, then what is the distance between house and office? Within a minute, you can answer this question, guys. We have discussed already the storyline of the question and we know which formula we have to use to answer to the question. So without any delay, try solving the question. This is nothing but home or house and this is nothing but office. So a man goes from his house to office with a 20 km per hour speed. Okay. So he is going with 20 km per hour speed and he reaches 15 minutes later. Let's say the actual time is t. He was 15 minutes late means it is t plus 15. Done. If he increases his speed by 5 km per hour, he reaches in time. So earlier it is 20 now. If you increase by 5 km, it is 25 km per hour and he is reaching in time. He is reaching in time means it is nothing but t. Then what is the distance between house and office? So what is the distance between house and office means in case 1, this can be case 1 values guys. Okay. And this can be case 2 values. So in case 1, you have a speed and you have a time. And in case 2, you have a speed and you have a time. Okay. So if you have taken the distance in case 1 as d1 and distance in case 2 as d2, you can write d1 equal to d2, which is nothing but s1 t1 is equal to s2 t2. So let's substitute the same and calculate the answer, guys. S1 is equal to 20 and T1 is equal to T plus 15. S2 is equal to 25 and T2 is equal to T. Done. So 20T plus 300 equal to 25T. So if that is the case, 25T minus 20T, it is equal to 5T. 5T equal to 300. T is equal to 60. What is the 60? 60 minutes. Why? Because 15 minutes late and then on time means we have considered with respect to minutes, right? Whatever the T value at the end you will get, the T value you have to take it into consideration as minutes. And if you want to convert it into hours, T is equal to 1 hour. You can write it as t equal to 1 hour. So either you can use D1 or you can use D2 to answer for the question. You will get the same, guys. See here, I'm solving for both. So if you are using for D1, so S1 T1, S1 is 20 and T is equal to 60 minutes you got, right? So 60 minutes plus 15 minutes. So this is 20 kilometer per hour. This is 60 minutes, 15 minutes. That's the reason I'm dividing it with 60. So 21s and 23s, 75 by 3, which is equal to 25. Okay, 25 kilometer. So if you feel like this is difficult, you can choose for D2, S2, T2. What is S2? 25. And T, you can write it in hours directly because you know it already. So 25 kilometer. You can solve using anything, guys, but make sure that when T is minutes, you divide it with 60 to convert that into hours. What's the answer for the question? Option B, 25 kilometers. So is it clear now? Are you clear with the question? S1 T1 is equal to S2 T2. Either you can use D1 or you can use D2 to answer for the question. Late means you have to consider it as plus. On like in time means it's the usual time. Let's go for the next one. So this is also the same logic, guys. But this time it's like early case, late case, and they were asking what is the approximate speed that he will be reaching on time. Distance 1 equal to distance 2. Object is train. Combination of trains and the time speed distance questions you can see here. Rajesh wants to catch a train. If he walks at the rate of 4 km per hour, he misses the train by 10 minutes. However, if he walks at the speed of 8 km per hour, he reaches 5 minutes early. What should be his approximate speed such that he reaches the station on time? So in case 1, if you see, speed is equal to 4 km per hour, and time, if you take, Rajesh misses the train by 10 minutes means if he was early, he will not lose, like he will not miss the time, right? So as he was late only, he was missing the train. So t plus 10. Try to understand this. Rajesh is missing the train by 10 minutes means if he was early, he will not miss the train according to the logic. Okay. If he was late only, he'll miss the train. So case 1, these are the values. S2 is equal to 8 kilometers per hour and T2 is equal to, he was 5 minutes early means that is T minus 5. So apply the same logic, D1 equal to D2, S1 T1 is equal to S2 T2. Okay. S1 is 4 and T1 is nothing but T plus 10. Next, S2 is 8 and T2 is nothing but T minus 5. So let's calculate this. 4T plus 40 is equal to 80 minus 40. If you rearrange 80 minus 40 means 40 equal to 80. That implies T is equal to 20. What is this 20? 20 minutes. Don't forget. Okay. T is equal to 20 minutes. Done. But what are they asking in the question? What should be his approximate speed such that he reaches the station on time? Okay. Approximate speed means you have to find out the speed for the distance and for the actual time. Okay. So what is the distance? Either you can take S1 T1 or S2 T2. Okay. So I'm taking D2 here, 8 into T is 20. Okay. Okay, let's substitute here directly the same. I'm doing it for D2 by T, guys. So D2 is nothing but 8. T is 20 minus 5. And this is minutes. 8 kilometer per hour. This is minutes now, divided by 60. Done. And T is 20 minutes, right? Divided by 60. So everything, the upper one, 8 is kilometer per hour, and this is also the time in hours. This is also the time in hours. 60 goes off, and here if you see 8 into 20 minus 5, it's 15 divided by 20. So 5 threes, 5 fours, 4 ones, 4 twos. So speed is equal to 6 kmph. So if you can understand it directly, then no need to write divided by 60 all the time, guys. If you can sense that it's in ratio already and it's gonna be cancelling out any which ways means, then you can write it out directly. So if you want, you can solve for D1 also, like D1 divided by T to answer for the question. Okay. So I'm reiterating the explanation once again. Please check it out. Rajesh wants to catch a train. In case 1, he was using 4 kilometers per hour speed and he was late by 10 minutes. He is missing the train means indirectly they were saying he was late. So it's T plus 10. And he is using 8 kilometers per hour speed and he was early by 5 minutes means it's T minus 5. Done. So in both the cases, distance is the same. If you apply, you can find out for time, and the time whatever you have got is in minutes, not in hours. Make sure that you are converting it into hours while the speed is in kilometer per hour for the options. So if you want to find out actual speed, that is distance by time, either you take D1 or D2. I'm taking D2 here and substituting the same, converting time of minutes into hours. I got 6 kilometer per hour as the answer. Okay. So clear with it, guys? Shall we go for the next question to solve? Yes or no? Please respond. Done? Super. Let's go for the next one. They can change the minutes of late and early, or they can change the names here. They can change the terminology, but storyline of the question is the same, guys. We have shortcut and we have conventional method also, but there are some limitations for shortcut, guys. Here, just tell me one thing. The question is based on point of time or period of time? The question is based on point of time or period of time? Respond. Okay. Point of time means 1 p.m., 2 p.m., 3 p.m. like that. Period of time means it's taking 2 hours, 5 hours, 3 hours, 4 hours like that. It's based on point of time or period of time? Point of time. So that point of time, we have to convert it into period of time to answer for the question. That's it. It is just to confuse you. They have given like this. I'll give a minute. Read the storyline in the question and try solving. Yes, done guys. So we can use the shortcut here. So let us discuss about the shortcut first. So Divya travels on bicycle at 5 kilometer per hour. She reaches her home at 3 p.m. Okay. So 3 p.m. and 5 kilometer per hour is the speed. If she reaches on bicycle at 10 kilometer, like if she travels on bicycle at 10 kilometer per hour, if the speed is equal to 10 kilometer per hour, then she'll be reaching by 1 p.m. Okay. So what is the speed that she have to maintain to reach the home at 2 p.m.? So they're asking for 2 p.m. Okay. So we can apply the logic of average speed here to answer for the question. When can we apply the logic of average speed means here if you see the question, the time period of case 1 is 3 p.m. and the time period of case 2 is 1 p.m. And whatever the time period that they are asking, if that is exactly between case 1 time period and case 2 time period, then it goes the same with the average speed, guys. It goes the same with average speed 2 S1 S2 by S1 plus S2. What is S1? S1 is 5 and what is S2? S2 is 10. So divided by S1 plus S2. So 5 plus 10 that is 15. 5 ones and 5 threes. We got it here 20 by 3. 20 by 3 is nothing but 6.66 kilometer per hour. 6.66 kilometer per hour. Option 1 is the answer. Try to understand when can we use the shortcut because we have limitations for this shortcut. Okay. This is nothing but point of time. So one speed we have it's 5 and the other speed we have it is nothing but 10. Done. And case 1 the time is 3 p.m. Case 2 the time is equal to 1 p.m. So if whatever the time that they're asking is exactly the middle value of case 1 time and case 2 time, then it goes the same with average speed. You can apply the average speed formula to answer for the question. Okay. So as 2 p.m. is exactly in between 3 p.m. and 1 p.m., you can use average speed formula to answer for the question. Okay. Can you give me some time 272? That's a shortcut. We have conventional method also. I'll tell both. I'm not even done with this shortcut. Okay. You just hold on for a while, guys. If I'm not doing that, then you can pose your questions. Okay. This is a shortcut. Okay. Now, here comes the actual part. What if the time is not exactly in between? So here, 2 p.m. is exactly between the value of 1 p.m. and 3 p.m., right? If that is the case, we can go with shortcut. Okay. But what if they have given like the time is 2:30 p.m.? What if they have given the time like 1:30 p.m. or 3:30 p.m. or some other value or some random value which is not exactly the middle value of case 1 and case 2. Okay. If we don't have the middle value of case 1 and case 2, we have to convert the point of time into period of time. Okay. Are you clear with the first model, guys? Are you clear with the first model? Just confirm me so that I'll erase the ink on the screen and we will discuss about the second model. When can we apply the shortcut? When case 1 time period and case 2 time period are having exact middle value of time period to be asked in the question, then it goes the same with average speed. Okay. So you can apply average speed concept here to answer for the question. That is the first method. Otherwise, you can use the shortcut of conventional method to answer for the question. So speed 1 is equal to 5 kilometer per hour, right? Done. And time 1. Time 1 is equal to 3 p.m. It's a point of time. Next. Speed 2 is equal to 10 kilometer per hour. Done. And what is time 2? Time 2 is equal to 1 p.m. What is the actual time? Actual time is nothing but 2 p.m. You can take reference of any value. I am taking actual time. Okay. If actual time you are taking it as t, this is 1 hour less, right? Then t2 will become t minus 1. So if actual time is equal to t, 3 p.m. means it is t plus 1, right? 1 hour more, right? It is t plus 1. Now apply the same thing. Distance 1 equal to distance 2, apply the same thing. S1 T1 is equal to S2 T2. Got the point how I have written it as T minus 1 and T plus 1? Whatever the point of time that they're asking, that I'm taking it as reference. If 2 p.m. is equal to T, then 1 p.m. is 1 hour less, right? So it will be T minus 1. So if 2 p.m. is T, the same 3 p.m. is 1 hour more, right? So it will become T plus 1. Okay. So S1 T1 is equal to S2 T2. Then substituting the same here, 5 into T plus 1 is equal to 10 into T minus 1. Solve for the value of T here. So 5t plus 5, 10t minus 10. Rearrange the terms. 10t minus 5t, it is 5t. That is equal to 15. That means t is equal to 3 hours. T is 3 hours, not 3 minutes. Okay. So why 3 hours means you have taken with respect to 1 hour of duration of time, right? Like t minus 1, t plus 1 means it's 2 p.m., 3 p.m. and then 2 p.m., 1 p.m. conversion. That's the reason t is equal to 3 hours here. Okay. T is equal to 3 hours means its duration of time. So actual time duration is 3 hours. Then case 2 time duration is t minus 2 na, it will become 2 hours. So it is t plus 1, right? It will become 4 hours. Okay. And what is the question that they're asking? They are asking for actual speed that they have to maintain to reach the destination at 2 p.m. So distance means either you can take this 10 into 2, 10 twos are 20. Okay. Otherwise, you can take this 5 into 4, 5 fours are 20. Any which ways is the same. So distance is equal to 20 kilometers divided by, and what is the actual time for 2 p.m.? It's 3 hours, 20 by 3. So 20 by 3 means 6.63, sorry, 6.66 kilometer per hour. Did we get the same using shortcut and conventional method? Yes. So we can use any form to answer for the question. But whenever we observe that whatever the time that they're asking is exactly middle value of case 1 and case 2, we can go with shortcut. And if that is not working, if they're not giving exactly middle value, then quickly you can take either T1 or the actual time of 2 p.m. or T2 as reference. From that, you can write what is the other point of times, and you can use the same formula S1 T1 equal to S2 T2 to answer for the question. Okay. Are you clear with